alkyl halides are an important class of organic compounds or functional groups in organic chemistry that contain an organic unit that is bonded to a halogen. And halogens are found in group 7A in the periodic table. This is the general structure of alkyl halides, Rx, where R is an organic unit, an organic portion, if you like, that contains obviously carbon. It's an organic unit that is bonded to a halogen, and a halogen could be F, Cl, Br, and I. Group 7A in the elements in the periodic table, halogens basically. So again, an organic unit that is bonded to a halogen. They are called generally alkyl halides or sometimes haloalkanes. So haloalkanes is also a possible general name for alkyl halides. A very important feature of alkyl halides is the structure of alkyl halides, which make them electrophilic or electrophiles in organic reactions. So the CX bond, this is the CX bond, is a polar bond. This is a very important structural feature of alkyl halides or compounds that contain CX bond. This bond again is a polar bond. And the polarity of this bond is induced by the difference in electronegativity between carbon and the halogen. The halogen is more electronegative than carbon. The halogen is more electronegative than carbon. So therefore, the halogen would pull electrons more toward itself in this chemical bond. So thus, X would be negatively polarized, or it would have a negative partial charge, and carbon would have a positive partial charge. So therefore, this bond, the CX bond, is polar, and that's because of the difference in electronegativity values between carbon and the halogen. And because of this, or because of the fact that carbon has a positive partial charge, alkyl halides behave as electrophiles. So this inductive effect, makes alkyl halides behave as electrophiles in organic reactions. So alkyl halides are therefore electrophiles because of the inductive effect caused by the difference in electronegativity values between carbon and hydrogen, or if you like, because of the polarity of the CX bond. Because of this, alkyl halides are electrophiles or electrophilic, so they behave as electrophiles, and this carbon that is directly bonded to the halogen is the electrophilic site. This carbon that is directly bonded with the halogen is the electrophilic site, or the electrophile site. So this is where nucleophiles attack this carbon. Because of this unequal shift of electrons, or because of this inductive effect, it is susceptible to nucleophilic attack. This carbon is the electrophilic site in the electrophilic alkyl halides in organic reactions. The other important consideration here, or discussion when we talk about alkyl halides, is the bond strength as we go down. So this is a table of halomethanes and the bond strength and bond length of the CX bond. A very important observation here is that if we go down the group, the 7A group or the halogens group, the bond strength decreases and the bond length increases. If we look at the carbon-fluorine bond in fluoromethane, the bond strength is 110 kilocal per mole and the bond length is 139 picometer. If we go to CCl bond in chloromethane, the bond length is 84 kilocalories per mole and the bond length is 178 picometer. This tells us that there is decrease in the bond strength, which means that the CCl bond, the carbon-chlorine bond, is a weaker bond than the carbon-fluorine bond, but also it is a longer bond. Looking at the bond length, the relative bond length of the carbon-chlorine bond relative to that of the carbon-fluorine bond. If we go further down the group, the bond strength decreases. So CBr bond is a weaker bond than the carbon-fluorine bond. The carbon-iodine bond is the weakest bond actually amongst the CX bonds. So carbon-iodine bond is the weakest bond and carbon-fluorine bond is the strongest. So perhaps we should label this. So this is the weakest CX bond, and this is the strongest CX bond. So carbon-fluorine bond is the strongest bond, and carbon-iodine bond is the weakest bond. But also the carbon-fluorine bond is the shortest, the shortest bond, because it has the smallest bond length of 139 picometer. So this is the shortest because it is the strongest. Obviously it is the shortest. This is reasonable. The stronger the bond, the shorter it is, of course. Yeah. So this is the shortest bond, and obviously the carbon-iodine bond, which is the weakest bond, should be the longest, and it is, giving the highest value for the bond length. So this is the longest bond, the longest CX bond in the halogens group, or group 7A. So to summarize this, as we go down the 7A group or the halogens group, the CX bond gets weaker and also it gets longer. The bond strength decreases and the bond length increases. Nomenclature of alkyl halides follows IUPAC rules. If we take this example, a very simple example of a compound that contains a halogen, something like that. So we follow IUPAC rules in order to name this alkyl halide. Of course, it is an alkyl halide because it's an organic unit that's bonded to a halogen. So we choose, according to IUPAC rules, the first rule is always to choose the longest continuous carbon chain, the longest continuous carbon chain. And obviously the carbon chain is 1, 2, 3, 4, 5, 6, 7. So of course that is longer than, say, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, if you consider this root. Yeah. So it's 7 carbons, therefore the root of the longest continuous carbon chain in this example. So there are, in this example, yeah, so 7 carbons, which means that the root is hept. Hept is the root, remember the root, and then what's after the root is the suffix. The suffix tells us about the functional group or the family of the organic compound. The root tells us about the number of carbon. Whatever we write before the root or the prefix tells us about the substituents or the branches that are on the chain. So the root here is hept, and since there is no other functional group, then it would be ane, yeah, just to reflect that this compound is an alkane, yeah, or an alkane, of course, containing a halogen. So hept-ane. Hept-ane. This is the name, the general name of this compound, reflecting the number of carbons, and the suffix suggesting that there is no other functional group except the alkane, which is not even considered a functional group. So then we should number the chain at the end closer to the first branch. This is the second rule, or the second IUPAC rule, is to number the chain at the end closer to the first branch. So if we number from here 1, 2, 3, 4, this methyl group will be at carbon 4. If we number from here 1, 2, 3, then the chloro group will be at carbon 3. So 3 is better than 4 because it is smaller. Smaller sets of numbers are always targeted or desired by, or recommended, if you like, by IUPAC system. So we number from here then 1, 2, 3, 4, 5, 6, 7. So that's how the numbering should be. Now we have a chloro group at carbon 3, so 3 chloro, and a methyl group at carbon 4, so it is 4 methyl. So 4 methyl and 3 chloro should be written before heptane. That's a prefix. So a prefix is the information that gives the part of the name that gives information about the substituents and also where they are located in the chain. So we have chloro and methyl, and we should also list them alphabetically, or we should use the alphabet to arrange them. So C in chloro is before M in methyl. So the name should be then 3 chloro, 4 methyl, and then heptane without any space. So there's no space between L and H. Letters are not separated in IUPAC names. So this is 3 chloro, 4 methyl heptane. If you notice also, a number and a letter are separated by a dash. Again here, letter and a number by a dash, number and a letter by a dash. Letter and a letter are not separated. So letters are not separated. A number and a letter are separated by a dash, and numbers are separated by a comma. So this is the IUPAC name for this compound that contains a halogen. Another important point here is that alkyl halides are named as generally alkyl halides, so alkyl halide or haloalkane. So this compound, for example, CH3I, if you follow this general nomenclature system, you will look alkyl halide. So the alkyl group is methyl. The halide is iodide. So this can be named as methyl iodide. So it's methyl iodide following that alkyl halide nomenclature guide, or you can name it as haloalkane, which means iodo, you would name it as iodomethane. So either methyl iodide or iodomethane. Of course, iodomethane is systematic. The methyl iodide is common, but both names are correct. Both names are acceptable. If you go to, if we take this example, yeah, okay, this can be named as isopropyl bromide. So this is isopropyl bromide. Isopropyl bromide. This alkyl halide is a tertiary butyl chloride. So this is a T-butyl chloride. So the name of this, the common name of this, of course, this alkyl bromide and this alkyl chloride can be named systematically by IUPAC groups, obviously. Yeah. So these are only the common names. This is isopropyl bromide because this unit is the isopropyl group, and this unit is the T-butyl group. So this is T-butyl chloride. So this is T-butyl chloride. T-butyl chloride. The idea here is that alkyl halides can be named sometimes by common methods, if you like, so alkyl halides instead of haloalkanes. Whatever the name is, okay, even if the name is common, the name can always be, or the compound can always be named by the systematic method or IUPAC rules.